Bismillahir Rahmanir Rahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum students. This is Hamza Noor, and here we have some questions from P1 differentiation rate of change. And first of all, we have March 2017 paper 1 variant 2 question number 3. The diagram shows a water container in the form of an inverted pyramid, which is such that when the height of the water level is h centimeter, the surface of the water is a square of side half h centimeter. Okay. Part one is saying that express the volume of water in the container in terms of h, and the information is given to you that the volume of a pyramid having a base area a and vertical height h is 1 over 3 times ah. Obviously, it makes sense because if this is the area, this is basically the base area, okay, which is a, and this is the height h. So in order to find the volume, 1 upon 3 multiply by the area of this square, which is supposed to be h over 2 squared, okay, and then multiplied by height, which is h. So 1 upon 3 multiply by h square over 4 and then multiply by h. So this is supposed to be h cube over 12. So volume is equals to 1 upon 12 times h cube. Just for 1 mark. Now the question is saying that the water is steadily dripping into the container at a constant rate of 20 centimeter cube per minute. The water is coming in the container, dripping into the container at a constant rate of 20 centimeter cube per minute. So we can say that the value of dV over dt, since you have only inflow, you don't have any outflow, the water is coming into the container, so dV over dt is equals to positive 20. Now part 2 is saying that find the rate in centimeter per minute at which the water level is rising when the height of the water level is 10 centimeter. When the height of the water level is 10 centimeters, so h is supposed to be 10 centimeter, and in this case what we need to find the rate in centimeter per minute. Rate in centimeter per minute. What is centimeter? What is actually represented by centimeter? The height actually. Now centimeter per minute means that dh over dt, change in height with respect to time. You need to find the value of dh over dt. Okay, so for this purpose, if you make a chain rule, we can say that dh over dt is equals to dh over dv multiplied by dv over dt. dh over dv multiplied by dv over dt. So basically this dv and dv is cancelled out, and therefore you will get the value of dh over dt. But at which point? At h is equals to 10 centimeter. So first of all, we need to find dh over dv. What we know the fact is that volume is equals to h cube over 12. Volume is equals to 1 over 12 with a constant term, and then h raised to the power 3. So if you find a function for dv over dh, so dv over dh is supposed to be 3 times 1 over 12 and then h squared. So 3 times 1 over 12 is basically, 1 over 4. So 1 over 4 times h square. This is your dv over dh function. But we are talking about at which particular instant? We are talking about the particular instant when h is equals to 10 centimeter. So just put the value h is equals to 10 into this function. You will get the value of dv over dh. So basically dv over dh at h is equals to 10 is basically 1 over 4 times 10 square. So 10 square is 100. 100 divided by 4 is 25. This is the value of dv over dh. dv over dh is equals to 25. But what we want according to the chain rule is dh over dv. So you will just reverse the fraction. So dh over dv is supposed to be 1 over 25. Makes sense. Multiplied by dv over dt. What we know the fact is that the value of dv over dt is 20 because the water is steadily dripping into the container. There is an inflow of water at a constant rate of 20 centimeter cube per minute, meaning change in volume with respect to time, 20 centimeter cube per minute. So dV over dt is supposed to be 20, and therefore 20 divided by 25, this is supposed to be our final answer, which is 0.8. This working was for 4 marks.